Okay, we're studying the graphs of polynomial functions. Here's some notation that we need to talk about so that you can use it on the graphs of polynomial functions. It's important and it'll come back when we work on limits. So what this says is, as x is going to negative infinity, the function goes up. So as x is going to the left, the function goes up. For example, it could do that. This is saying as x is going to positive infinity, which means to the right, the function goes up. So x going to negative infinity is as we look at the function to the left. X going to positive infinity means as we look at the function to the right. Okay, here's another one. As x goes to negative infinity to the left, the function goes to positive infinity. So that says on the left, the function goes up. As x goes to positive infinity, that's on the right, the function goes down. So on the right, the function goes down. As x goes to negative infinity, on the left, the function goes down. So on the left, the function goes down. As x goes to positive infinity means on the right, the function also goes down. Down on the left, down on the right. Find the x-intercepts of the function. So we're going to set the function equal to 0. To find the x-intercept, you set y equal to 0. And in this case, we're going to factor, and then we're going to split, and then we're going to solve. So x is equal to -4 and +4. Those are the two x-intercepts of the function. Which of the following is an x-intercept of the function? So if we plug in x equals -3, we get -3 squared plus 7 times -3 plus 12, which is 9 minus 21 plus 12, which equals 0. If you plug it in and you get f of that number equals 0, that is an x-intercept. So if we start plugging in more and we happen to plug in -4, so we get 16 minus 28 plus 12 equals 0. F of that number equals 0, so this is also an x-intercept. Write a polynomial function that could be graphed below. Notice our function crosses at -4, bounces at -1, and crosses at +3. So here's an example of what that function could be. -4 is a root where it crosses through, so we're going to call that a single root. It bounces at -1, so we're going to call that a double root. And +3 is a single root. So here's an example of what the equation could be. What is the maximum number of positive extreme values for the function? If the degree of the function is 7, the maximum number of positive extreme values equals 6. It's one less than the degree of the function.